Hello, algebra students. Mr. Lawrence here, and we are going to work on some literal equations over the next 2 days. But let me talk about one thing before we do. All right, inverse operations. Remember, it is very important to know your inverse operations. I know you all know that addition and subtraction are inverse operations, meaning they undo each other, right? Okay, I can use addition to undo subtraction, and I can use subtraction to undo addition. But I'll bet you also knew that I can do the same with multiplication and division, right? Okay. Now, one that gives you trouble sometimes are exponents, because you think of exponents as multiplication. Look, if they were just multiplication, they wouldn't call it exponents. It would just be another multiplication, right? Now, it's true that there might be multiplication going on, but when I have 2 to the third power, we don't think about that as 2 times 3. That is not 2 times 3. That's 2 times 2 times 2. Oh, not times 3. Sorry about that. So please don't think about exponents like as multiplication anymore. They're different in the order of operations. They're not the same thing. Some of you a long time ago said, oh, exponents, it's just multiplication, no big deal. And when you did that, you retarded your understanding of mathematics, meaning you stopped it from growing. And that's why you don't know how to undo exponents. You want to divide, and that won't work. We use roots to undo exponents. For example, if I wanted to take the square root of 16, what is the square root of 16? Well, some of you are going to say 4, and I wholeheartedly disagree with you. It is not 4. And I'll ask you, why do you think it's 4? And you'll say, well, Mr. Lawrence, I know it's 4 because 4 times 4 is 16. So the square root of 16 must equal 4. But I don't agree, because I know another number. 4 times 4 is 16. I don't disagree with that. But 4 times 4 is 16. But what about negative 4 times negative 4? Well, it's also 16, isn't it? So you see, the square root of 16 is plus or minus 4. There's 2 answers there. Okay, if I wanted to take the cubed root of a number, say like 125, I'm asking myself, what number times itself again equals 125? All right, I don't know if you know this yet, but in this case it would be 5. Next is going to equal 5. So we use roots to undo exponents, okay? So let's go on to these little equations. We'll come back to that. We did some of these a little while ago, but we're going to review it here. We've got this equation that we use so much that first several weeks of the first quarter. D equals RT, distance equals rate times time. And I want to solve it for T. Well, you do understand that D is a number, an unknown number, the unknown distance. R is a number, it's the unknown rate. And T is the unknown time. So if I want to solve it for T, I want to get the T alone. Well, what's keeping the T from being alone? The R. How are they attached? Multiplication. So therefore, to undo it, I will divide by T on both sides. And excuse me, I'm trying to solve for T, silly me. I'm going to divide by R on both sides. No, yeah, I'm going to divide by R. All right, so I'm going to cancel the R's. I'll get T, and then it'll equal the distance divided by the rate. And that's how we can figure out the time. And you have had a lot of experience with this earlier in the first quarter. Let's take a look at the second version here, D equals RT, but I want to solve for R this time. So I ask myself, what number is attached to R? Well, in this case, it's a T. It's attached by multiplication. I want to undo that. I'm going to divide by T. And so in this case, the distance divided by the time is going to equal R, or the rate. And there you go. All right. Now, how about this one, the Pythagorean theorem? A squared plus B squared equals C squared. I want to solve it for C. Well, right now I have C squared, not C. Well, how do I undo a square? I use the square root. but I have to use the square root of both sides. And so when I do that, these cancel each other, and I get c is equal to the square root of a squared plus b squared. If you want to check that out sometime, try it. Take a right triangle, okay? Tell you what, let's say this side is 3 and this side is 4. We don't know this side. This is c, right? Because it's across from the right angle. It's the hypotenuse. If I want to find c, I can just take the square root of 3 squared plus 4 squared. Kind of skipping a step here, but showing you that this will work. 9 plus 16, square root of 25. And of course the answer is plus or minus 5, but since we're talking about a distance, it's impossible to have a negative distance. And so in this case, we'll ignore the negative of the square root. That gives us a negative answer. We'll only use the positive answer. Okay, the positive square root is also called a rad. Well, how would I solve this for a? Well, I want a alone. First, I'm going to get rid of this plus b squared. I'm going to subtract b squared from both sides. And so I'm going to get a squared is going to be equal to c squared minus b squared. And then to undo the exponent, now in case you're wondering, normally we listen to Saddam, but if I'm working with exponents, I'm going to listen to SADME. All right, I'm going to undo the addition first. That's what I did by subtracting b squared. And now I'm going to undo the square by taking the square root. Notice I have to do the whole thing there. So I'm going to get a, and that's going to equal c squared minus b squared. Okay, it's kind of a shortcut formula for finding a side of the Pythagorean of a right triangle. All right, similarly, you can find that b would equal square root of c squared minus a squared if you went ahead and solved that for b. All right, now maybe even more important is an equation like this. It's a linear equation. It's actually something we call in standard form. We'll learn more about that later. I'm going to solve for y. So y is the variable I want to get alone. I'm going to ask myself, what numbers are attached to y? Well, I have a 2x, and the 2x is attached by addition, and I have a 3, and the 3 is attached by multiplication, right? See, I'm treating this 2x just as a number, as if it was a 5 there, or a 12 there, or something like that. So I'm going to get rid of the 2x first, and I'm going to make a small suggestion here. Of course, the left-hand side is just going to be 3y. The right-hand side, many of you are going to want to write 6 minus 2x. And I'm going to make a small suggestion. Write the x term first. You will see why later. I'm telling you, it's going to be easier if that x term is first. It's going to help us with the type of graphing we're going to learn a little bit later on. All right, now, y is not alone. There's a 3 there attached by multiplication, so I'm going to divide by 3. Now remember, when we multiply or divide both sides of an equation, I have to do it to all the terms. I have to distribute. Here, the 3's will cancel, and I'll get a y. Nothing's going to simplify there. I'm going to write a minus 2/3 x. And 6 divided by 3 is 2. And there you go. Y is alone. Okay? Same equation. This is a linear equation. All right? This is a linear equation. They're written in two different forms. At some point, we're going to graph them, and you'll see that they would produce the same exact line. I haven't changed the equation, I only changed the way it looks. All right, one more of those. Okay, so we're going to solve for y again. I just have a habit of circling my y. All right, I'm going to ask myself, what numbers are attached to x? Well, I have a 5x, and that's attached by, it's a positive 5x, so it must be addition. And I have a negative 2. See the negative 2? And it's attached by multiplication. All right. Saddam tells me to undo the addition first, so I'm going to subtract 5x from both sides. Because I listened to Mr. Lawrence's hint a few minutes ago, I'm going to bring down the negative 2y. These cancel. And I'm going to write the negative 5x plus 10 just like that. Now, I don't know why I'm doing that. I know Mr. Lawrence suggested it. I'm going to trust him. Later on, it's going to make things easier for me. All right, so now I got to get rid of this negative 2. Well, I'm going to divide by negative 2 in all 3 places, okay? The negative 2's will cancel. I'll have y equals, now this won't simplify. You might want to go mixed number here. Don't go mixed number. Don't go mixed number. Go improper fraction. You'll see why later. I do know the 2 negatives will cancel each other. A negative divided by a negative. So I'm going to go 5 over 2x. And 10 divided by negative 2 is negative 5. And there we go. I just solved for y. Let's do one more of those just because they're so important. Let's go with a 4y minus 5x. And let's make that equal to, I don't know, negative 20. All right, and let's solve for y. Solve for y. Okay, so I go through my questions. What is my goal? To get the y alone. What numbers are keeping the y from being alone? Well, there's a 4, and it's attached to the y by multiplication, right? There's also a negative 5x, and it's attached by subtraction because it's a negative 5x, right? So I'm going to listen to Saddam and get rid of the negative 5x. So I'm going to add 5x to both sides. I'll get 4y. Oh, not yy. 4y. Oh dear. 4y. Those two will cancel. I'll have negative 20 plus 5x. But Mr. Lawrence suggested writing the x term first. Again, he didn't tell me why. I'm going to trust his experience. All right, now I need to get rid of this 4. It's attached by multiplication. I'll divide. I'll divide. And I'll divide. All right, the 4's are going to cancel. I'll get y equals 5/4 x minus 5. All right, there we go. Okay. Let's see here. Let's go to the Visio quiz here. And I'm going to give you a hint when you do it. Okay. Remember to use inverse operations. Ask yourself, what is attached to the variable I'm solving for? On number 1, I'm solved for m, right? So I have to ask myself, what's attached to it? How is it attached? I won't take a square root on this one. If I was solving for c, I would take a square root. But I'm not going to solve for c on this one. I'm going to solve for m. So there won't be any square root. And this one is actually a one-step equation. There's one step to get m alone. All right, number 2 is just like those 3 examples I did. Same thing. Okay, go ahead, rewind the video if you need to see how to do number 2 again. All right, Mr. Lawrence signing off. Have a good night, everybody.